In this session, we are going to look at inheritance. The purpose of inheritance is to let one class pass everything to a different class. This concept helps with the drop principle, which stands for don't repeat yourself. It helps to reduce code duplication and support code maintenance. Therefore, we do not have to start from scratch when creating a new class. For example, right now, I have a class called employee. The employee class will be our parent class, also known as superclass. It has information that will be inherited by a child class, also known as subclass. The information are class variables, attributes, and methods. The methods are initializer, which is the init method. Also get employee info method plus the add bonus to salary method. A child class is a specialized version of a parent class. Therefore, good candidates for child classes are developers and testers because they are specialized employees with unique skills to write code. When it comes to the drop principle, an engineer not respecting that principle would copy all of this information and paste this information into a new class called developer. But this defeats the drop principle because we should not repeat the same code for a few reasons. But one of the reasons involves a possible update to our code. A requirement may change to make a function such as int to float. As a result, the code would change in two locations and not one location. When I run, we see the value change to a decimal for salary and bonus for John Doe and Jane Doe. I'm going to change it back to int. So the value is a whole number. Plus, I'm going to remove this duplicated code in the developer class and only write pass. In the previous session, I mentioned pass is a placeholder for future code. Let's say we want to create a specialized version of the employee class. To inherit, we write the name of our parent class in parentheses after specifying the child class. The developer inherits the employee class. To verify the inheritance, we start by writing a built-in function provided by Python that is called issubclass. We pass in the child class, which is developer, followed by the parent class, which is employee. This statement will return true or false, but it will return true because the developer class is a subclass of the employee class. Yes, we see true. Now, we can write as many subclasses as we need to complete our program. At this point, the developer class will automatically inherit all of the values, such as the attributes, variables, and methods from the employee class, all of the information. Let me demo the inheritance by writing imp1. Now, we already have imp1 for employee. So I'm going to go ahead and erase all of this information from the previous session and write imp1 developer. Do you see self, employee, name, imp num, and salary? That show the relationship and which arguments to pass. Name is developer John. Employee number 1. Salary is $120,000. Also instantiate M2 equals employee. Name employee Jane. Employee number 2. salary $110,000. Recall the developer class is empty and only have pass as a placeholder. However, developer has access to the employee class by writing emp1 and a dot operator. The dot operator provides access to the variables, attributes, and methods. Notice we see emp num, name, salary, bonus, add bonus to salary, the initializer, get employee info, total employees from the employee class. How about we call the add bonus to salary method? Print the value for employee 1 and employee 2, which are in two different classes. I'm going to write employee 2. And when I run, we see $130,000 for developer John and $120,000 for employee Jane. With inheritance, Python allows us to customize the child classes with more information than the parent class. We initialize the developer subclass with its own init method. Go to the parent class, which is employee, and only copy the init method because there is no need to copy the instant variables. So when I go back to the developer class, I'm going to paste the init method. Now, at this point, we can add another attribute. The extra attribute will be lang, which is short for programming language. Now, create the instant variable by writing self.lang equal to lang. Next is to call the init method from our parent class. There are two ways to call the parent class. One way is to use super, and the other way is to not use super. Let's start by using super as the keyword, parenthesis, dot, followed by 2 underscores, init. Then we're going to add the attributes name, employee, number, and salary. This statement connects the employee class, which is the parent, to the child class developer. Notice our background for the developer instance is now brown. This is an error because we must include another argument since we added the lang attribute. Let's write another argument by writing Python as the programming language. Now the error goes away. We can print lang for Python by writing print employee 1 is a emp1 dot and call lang. I'm going to add another comma, then write developer. When I run, the console shows Python for employee 1 is a Python developer. The next class, let's call it tester. And it will also inherit the employee class. Define this init method by writing def 2 underscores init self. And the attributes will be name, emp, num, comma, salary. Now I'm going to write another attribute called web mobile. Web mobile is the customized attribute for our tester class. Create an instance variable by writing self.web_mobile equal to web_mobile. The other way to call the parent class init method is by writing the class name employee dot underscore init. Now, when we call using the employee class, the parent class name, we must add self. Now, notice the difference. Using super does not use self, but employee must use self. And then we can write the attributes: name, employee number, and salary. We generate an instance of the tester class by writing M3. I'm thinking about printing the value. M3 equals tester. And the name will be, how about we say tester James. Employee number 3, and the tester makes $100,000. And we're going to pass in, how about we pass in web for the other attributes. Now, we print the value for web by writing employee 3 is a comma emp 3 dot web mobile tester. Now, when I run, we see employee 3 is a web tester. That's it for Python inheritance. Thanks for watching, and I will see you in the next session.